Today we are going to talk about cosine law. There are cases that in a non-right triangle, sine law is not advisable. You cannot use sine law. What about solving the problem? It turns out that you have to use another law which is called cosine law. Consider a case of a triangle ABC. Let's say these two sides are given and this angle between them, which we call the contained angle, is also known. As you remember from the sine law, you can use sine law if you have two sides and an angle which is not between the two sides. You cannot use the sine law here because when you write the equivalent ratios, you will end up with two unknowns and one equation, which is impossible to solve. In cases like this one, we are going to use the cosine law. Now, when is cosine law applicable? We use cosine law if we know two sides and the angle between them, or we call contained angle, like this triangle, this side, and the angle between them, or if you know the three sides of a triangle. In either one of these cases, cosine law is going to work. And it's obvious that sine law is not applicable in any one of these cases because you don't have two angles. Now, the cosine law, again, a repetition of grade 10 and 11, says that any side square, for instance, in this triangle ABC, side c squared is equal to the sum of the square of the other two sides AB, so it's going to be a squared plus b squared minus twice the product of a and b times the cosine of the angle between them. Now, this cosine law can also be written for the other two sides. For instance, to write the cosine law for side A, I can write that a squared is equal to b squared plus c squared minus 2bc cos of angle between the sides b and c, which is angle A. At the same time, I can write b squared is equal to a squared plus c squared minus 2ac cos of angle between them, which is b. Now, there is no easy way that I can tell you, how to memorize this formula. The only thing is that whatever side which is the square on the left, the angle in front of it is going to appear on the right. And the sum of the squares is the sum of the square of the other two sides. And the product here is the product of these two sides. Now, let's do a couple of examples here. Before I go to examples, let's see when you can use the cosine law. The cosine law can be used in two situations: when you have two sides and angle between them. Two sides and the angle between them, or if you have three sides. In either case, use cosine law. Do not try the sine law because it's not going to work. Now, the first problem. You have a triangle MNP. Side MN is 25, NP is 13, and the angle contained or between them is 105. We are supposed to find N. Since we have two sides and the angle between them, I'm going to use cosine now. So we are going to write N squared is going to be 25 squared plus 13 squared minus 2 times 25 times 13 times the cos of angle between them. If you simplify the right hand side, we get that N squared is going to be equal to 962.23. If I take the square root of both sides, I'm going to get N is approximately 31.01 centimeter. Now the second example. We have another triangle, CBD, and we are supposed to find angle C. Now looking at this triangle, you can see that three sides are given, so automatically we know that we will use cosine law. And none of these angles is 90, so no trig ratio can be used. So since I'm going to I'm going to try to find side angle C, I'm going to use side C, which is in front of it, on the left side of equality. So I'm going to say 750 squared is 500 squared plus 650 squared minus 2 times 500 times 650 times cos of angle between them, which is C. Now I'm going to bring this product to the left and change the sign, and this one to the right and change the sign. So I'm going to get 2 times 500 times 650 cos C is equal to 500 plus 650 squared minus 750 squared. Now I'm going to divide by 2 times 500 times 650. So these are going to cancel each other out, so I'm going to find that cos C is 500 squared plus 650 squared minus 750 squared divided by 2 times 500 times 650. Now, if I simplify this ratio here and then use the inverse cos on my calculator, I find that C is approximately 80.26 degrees. Now we are going to do the last question. This is a word problem. We have an air traffic controller at T, which is here. There are two planes, one here and the other one here. What we are supposed to do is to find the distance, meaning T, between the planes. The information given here is the following. The distance between the plane at U and the air controller is 10.7 miles. The distance between plane V and the air controller T is 15.3 miles. The angle between the line of sight from controller to plane U with vertical is 23, and the same for plane V is 75. The first thing I'm going to do is that I'm going to find this angle between the two eyesights from the controller to two planes. So I'm going to say that angle, let's call it theta. Angle theta is 75 minus 23, which is going to be 52 degrees. Now, to find t, I'm going to use the cosine law because I have two sides and the angle between them 52 degrees. So I'm going to say t squared is equal to 10.7 squared plus 15.3 squared minus 2 times 10.7 times 15.3 times cos of 52. If you simplify this one, you get t squared is 147 approximately. So t, if you take the square root of both sides, is going to be about 12.12 miles. So we found the distance between the planes is 12.12 miles.